Hi, welcome back. Hello.
Hi.
Good morning. Hello. We're continuing our explorations of those linear functions, those straight line functions. And today we're going to be changing them into some other kinds of straight line functions. And the way we do that is this way. We've got 4 different ways to do it. Let's look at the one on the top left. This is a change when we add something to the output of the function. So I have some function f of x, and I'm going to add something to the tail end of it. Whenever I'm adding something to the output, it's going to be called a vertical translation. And when the thing that we're adding is a positive number, we're going to go up. And when the thing is a negative number, we're going to go down. Seems pretty easy, yes? Shift it over to adding something to the input now. And it looks like this. We're going to take our function and we're adding something, but now we're inside the parentheses. So we're doing something to the input because we're inside the function. When we're adding to the input, it's going to be called some sort of horizontal translation. Now, this is going to feel backwards from the vertical translation, because when c is positive, we're going to move to the left. And when the thing we're adding is negative, we're going to shift it to the right, which feels backwards because normally to the left is negative and to the right is positive. But when we're dealing with translations, when we're adding something that's positive, it's going to shift left, and when we're adding something negative, it's going to shift to the right. All right? Okay with that? Okay. Come over to the output. When we multiply by the output, so notice now our function reads some number times our function. This is going to cause some sort of stretch or compress, and the number we're multiplying by will decide whether it's a stretch or compress. It also controls whether we have any kind of reflection happening or not. Okay, so here's what's happening. When a is going to be bigger than 1, our function is going to stretch away from the x-axis. Okay, so here's my little string. I'm going to color it in yellow. There it is. And if I'm multiplying this number here by, like, say, I don't know, 40, I'm going to take this string and I'm going to stretch it this way. Okay? So those numbers are getting pulled further away from the x-axis. The graph, the function is getting taller. If the thing I'm multiplying the function by is a fraction, small fraction, somewhere between 0 and 1, the function is going to get closer to the x-axis. It's going to compress. It's going to shrink down toward the x. Okay? Jiminy is trying to add something. Make sense?
Yes.
All right. If the number we're multiplying is a negative, that's when we're going to have some sort of reflection. And when it's negative, it's going to reflect across the x-axis when the multiplication is happening to the output, to the entire function. Okay? So if our function looks like this, come on up. I'm doing something with my hands here. And you have to imagine that your x-axis is going to be between my hands. That negative is going to cause it to flip so that the function now looks like that. Okay? Do you see that? All right. What happens if we multiply by the input? Notice now that the multiplication is happening again inside. If it's bigger than 1, we're going to be getting closer to the y-axis. We're getting thinner. It's stretching this way, like getting compressed in toward the y-axis, getting to be a straighter and straighter line. It's going on a diet, okay, when you're multiplying by a big number. If you're multiplying by a really small number, some sort of fraction between 0 and 1, your fraction is going to get spread out away from the y-axis. It's going to get stretched in this direction, kind of like me on Thanksgiving Day. It goes fat. If it's negative, that's when we have our reflection, but this time we're going to reflect it across the y-axis. So if it was here, reflecting across the y-axis is going to make it look like that. Make sense? All right, let's do some practice problems on our handy dandy worksheet. Hang on to your notes. Keep them close at hand. We're going to refer to them. Looking at the first 6, we're matching the function with the description of what this thing is doing to the function. As you're looking at these 6, please pick the one that looks the most intimidating to figure out to you.
5.
The last one, 5 or 6. Okay, so let's look at 6. 6 will be the one I look at. So if I look at this one, here's my function f of x, and it looks like I'm multiplying to the outside. So I'm multiplying by the output. That means I'm looking at this part of my notes. If it's bigger than 1, it's going to be some sort of stretch. If it's smaller than 1 but bigger than 0, it's going to be some sort of compress. And if it's negative, it's going to be a reflect across the x. It's a negative, so it's a reflection over the x. That's all you're doing for this section. Okay? So use those notes at hand and have that argument with yourself as to what those symbols are doing. Okay? I have a typo in the problems on the bottom. Look at number 9. This right here should read H, not G. Now that H and G, those are just other ways to name functions. You've seen them so far as f of. That f stands for function, so it's the function of x. But if we have more than one function in the same problem that we're trying to talk about, we can't call them all f because it gets confusing. So we're going to just start going down the alphabet. F, G, H, I, so on and so forth. Or if this function, hi, welcome to physics, is being used to explain something, then you typically see the name of the function as the first letter of whatever the thing is that you're trying to explain. Like, this is a function that dictates the height of a ball when you throw it. And so typically it's h of, and then whatever variable we're using to track time. It's usually t. Okay, so if you're using maybe a distance function, you want to see how far away something is when you throw it. Maybe instead of height, you're going to use d for distance, and then again, your variable would be, I don't know, something like t for time. Okay, so if you're taking physics, hopefully, is anyone taking physics in this room? Yeah. Like more than half of you are taking physics. Nice. Okay, so I just helped you in like 3 more weeks when you get to those weird equations. You're welcome. All right, which one of these 6 is the most intimidating? Okay, pick the one that's the most. 12. All right, 12 because we have a fraction and a thing and there's additions and it looks squiggly and weird. Okay. First thing I'm going to do is I'm going to graph this function. I'm going to graph that just like a regular line. That's an intercept at 1. I have a slope of positive 1/2, so I'm going to go up 1 and over 2.
Wait. That's 2 on the right and put it on 2.
Oops. Ignore these. Thank you. Someone was watching and thinking what they were doing instead of copying mindlessly. I love it. Thank you. Yes. Holla, shout out. I'm going to make little tickets for you to give me. And I'm going to have you write me up for making a mistake. We'll post them on the, you know what? We'll post them in the parking lot. Get me to finish that. You write down what my mistake was that you caught me doing, and then we'll put it there and see how quickly we can fill up that board.
That's what the parking lot is?
The parking lot is for little notes and things that we want to leave each other.
You went up to...
It's not sticky. So I would either buy a whole bunch of sticky notes or figure something else out. I don't have, yeah. Well, then you can't take them off. Yeah, it won't come off. Look, I have a plan. I just need to execute. Okay. Here's the first one. So now I'm going to write the name of this. You distract me. You're so good at it too. You guys are masters at distracting me. All right. Now let's look at our translation. What kind of translation is this?
Or, no.
Yes. It's a horizontal translation because it looks like this. And when the thing that we're adding inside of that function is positive, we're going to shift to the left. If it's negative, we're going to shift to the right. It's positive, so we're going to shift to the left. All right, here's how we're going to do this. Grab any point that's on this line. I'm going to use this one. And I'm going to count to the left 5 places. 1, 2, 3, 4, 5. I'm going to put a point there. I'm going to do it again to any other point that you want. I'm going to use one of the ones that I graphed because I knew where it was. 1, 2, 3, 4, 5. And then I'm going to trace this line with my handy dandy straight line maker. Boom, boom. I'm going to label this as h of x plus 5 to show that it is this transformation. And then I'm going to take the highlighter that I used to show that it was the transformation, and I'm going to highlight that line to make it really different from the original. And that's it. That's all you do. Questions? Comments, concerns? Suggestions? All right, when you're ready, flip the page and join me on the back. Looking at the top, I have another typo. It's the day for them. Look at number 18. I got happy fingers. Yeah, I put too many equal signs. Just get rid of one of the equal signs. You're good. My bad. All right, of these 6, which one is the most intimidating to look at? 18? 18, the one I typoed on.
Yes.
Okay, let's just put that out there for the whole internet to see all of my typos. Look, it's okay. I can take. You can leave a comment and tell me how. Learn to type. Okay, I'm going to graph this line, positive 2. Down 3 to the right 4. 1, 2, 3. 1, 2, 3, 4. Take my straight edge maker. I'm going to turn my paper so it's easier for me to do this. Make sure that you're putting your arrows. And then I'm going to copy this function stuff here. And again, I'm turning my paper to make it easier for me to write. So this is h of x equals negative 3/4 x plus 2. And now I'm going to do the transformation. What kind of transformation is this?
Right.
Oh, vertical. No, wait.
The one.
The bottom right, which I didn't give a name because I'm a bad person. Let's give it a name. We'll call this a horizontal stretch or compress. And there's a reflection involved, which means that the multiplying by the output is going to be some sort of vertical. Might as well go ahead and jot that in there. So horizontal and vertical. All right, so this is some sort of horizontal stretch, compression, or reflection. Which one is it?
It's a reflection.
It is a reflection because it's a negative and I don't have any other numbers. So it's a -1. And according to my notes, it says it's going to reflect across the y-axis. What that means is I'm going to take the points and I'm going to see how far away they are from the y-axis. This particular point is 1, 2, 3, 4 units from the y-axis. So on the other direction, I'm gonna go 4 from the y-axis. 1, 2, 3, 4. Put a point here. Now I need to find some other point to move, or I can find a point on the y-axis. Because if a point is on the line of reflection, it doesn't go anywhere. So I'm going to connect this point to this point. Now if you want to be certain, look, here's another point you could use way up here. That point is 1, 2, 3, 4, 5 from the, with a y thing. Is that right on? No, no, that looks like it misses. Let me grab this one, because that one looks closer. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Yep, and that should go right through that y-intercept again, if I did this right. Boom. And I'm going to label this one. This is h of negative x, and I'm going to highlight it. That's it. That's all there is to this. Any other questions? Thank you very much.